Hi everyone. Today we'll start off by talking about various terms and notations that you'll probably encounter during your time learning material and energy balances, along with an introduction to the general balance equation. Every problem that we'll deal with will revolve around a certain process, or rather making a thing do something with a goal in mind, like when you try to convince your parents that you're not a chemist so they respect you more. There will generally be inputs or feed and outputs or products going through a unit. These can also be called process streams. We can either deal with mass flow rates or molar flow rates. In every process we deal with, we want to maintain a consistent basis of calculation, or rather just choosing between mass or molar flow rates. Later on, it may be easier to deal with one basis more than the other. But right now, just make sure you're not trying to use both at the same time. In a process, we could also have as many components as we want, like adding hydrogen and oxygen in a feed stream to make water for the product. To do this, we can denote either mass fractions or molar fractions, whichever aligns with our basis of calculation. We can also identify the type of process based on how it's operated, like a batch process, where you can add the reactants together and then come back and remove the products later on. We also have continuous processes, when the feed and product streams keep flowing until the process is stopped. There's also semi-batch processes, which basically said screw you to batch and continuous and became both at the same time. All of these classifications can either be steady state, not changing with respect to time, or transient, which does change with time. Now that all of that stuff is out of the way, we can talk about the general balance equation. If we were operating in real-world conditions, we would have this equation where input plus generation minus output minus consumption equals accumulation. But we operate in textbook world, so we'll just ignore accumulation. So now we just have input plus generation equals output plus consumption. Or even better yet, it's as easy as in equals out, like your professor probably said about 5 times in the first lecture. For now, we won't really deal with generation and consumption, not until we deal with combustion and reactive processes. We also want to make sure in equals out is at the forefront of our brains. No matter how complicated it may seem, it really is that easy. If we don't, we'll end up with negative flow rates and no one likes that. That's all for this video. Here are some questions to help test yourself on what we learned, and I'll go over the solutions in the next video.